Hi everyone. In this video I'm going to demonstrate how to perform path analysis using Stata. In particular, I will demonstrate how to use the drawing program in order to draw out your model, and then various options for obtaining output that is pertinent for evaluating the fit of your model to the data. Now before we get started, let me note that you can actually obtain a copy of the data that I will be using at this link right here, and I will make this link available underneath the video description. So the data is actually fictional data. It's fictional student data, where we have measures of performance goals, student achievement, mastery goals, interest, and anxiety. So those are the variables that we are going to be working from in this presentation. I also want to mention too that underneath the video description I will include a link to this PowerPoint that's opened up. It contains screenshots and additional information that I may not necessarily get to all in this single video, so be sure to check it out as well. Now before we open up Stata and begin analyzing data, let's take a look at this first model that we are going to be working from. So this is just a screenshot using the SEM builder. Basically this is a diagrammer in Stata. And you'll notice that in the diagram we have boxes and arrows. So the boxes represent observed or manifest variables within SEM notation. So all of these variables are observed in the data. They're directly observed. The arrows represent proposed causal association. So you'll notice that we have an arrow pointing from mastery goals to interest. So we are proposing that that students' mastery goals are predictive of student interest. We've got interest predicting achievement right there. So basically, student interest ought to be predictive of student achievement, and so forth. Now you'll notice that we also have these three boxes, anxiety, interest, and achievement. All of them have an oval or a circle next to them with an arrow pointing to them, and this is reflecting prediction error. So the idea is that any variable within your model that is being predicted by other variables within the model, they will have prediction error associated with them. So the interest variable, anxiety, and achievement variable, all three of these variables are termed endogenous within the model. So these variables are being predicted by models by variables that are upstream. And you can also have endogenous variables predicting other endogenous variables. So you'll notice that whereas we've got interest and anxiety being predicted by mastery and performance goals over here, we can also have achievement being predicted by interest and anxiety. Now the mastery and performance goal variables that you see right here, these don't have error terms associated with them. So we're taking the variances of these variables as is. These variables are termed exogenous within the model. So in other words, we are using those variables to explain variation in the endogenous variables downstream, so to speak. You'll also notice that we have a double-headed arrow between mastery and performance goals, and this is common with the exogenous variables within your path model. So that is definitely something to consider including when you are specifying your path model. Otherwise, the path coefficient, say from mastery to interest, right there will not be adjusted for the fact that performance goals is correlated with mastery goals. And you can also see that we have performance goals also predicting interest. So just kind of keep that in mind, that we want to adjust those path coefficients for covariation among the exogenous variables within your model. Okay, so here I've opened up Stata, and the data is already available in memory. So what we'll do is just take a quick look at it. We'll go under the Data tab, go to Data Editor, and then go under Browse. And you can see we have our variables. There's performance goals, achievement, mastery goals, interest, and anxiety. So we'll click out of that, and let's go ahead and open up the drawing program. So I'm going to click under Statistics, go down to SEM, Structural Equation Modeling, then Model Building and Estimation. So when we do this, this drawing interface opens up, And you can see that we can resize it. We can also we can minimize it if we wanted to, and so forth. You can also see that under settings, right now I have it the default. It looks like 142%. I'm going to actually shrink this down a bit to 125%. And you'll notice that on the left of the drawing surface right here, you've got various icons so that we can draw out our model. So we'll start off by drawing out the manifest or measured variables by clicking on this rectangle right here. So when we do this, by the way, if I highlight over this, it says add observed variables. So now you can see that I can just draw out, that's going to be for the mastery goal variable, that will be for the performance goal variable, this will be for the interest variable and the anxiety variable, and then for the achievement variable. So I want to select off of this, so I'll just go ahead and click on this little button right here, the arrow. And now I want to add the variable names to them and basically specify which boxes are associated with which variable. So I'm going to click on this box right here, this first one. I can use a little drop down right here and then go down to mastery and select it. And do the same thing for this one right here. We'll just go down to performance goals. We'll do the same for this one. We'll go down to interest. Then we'll do anxiety right there, and then this one right here will be our achievement variable. So now I want to draw in my arrows, and so you'll notice that I don't have any of those residual terms included for my 3 endogenous variables, but we can add those. Those will actually be activated automatically by drawing in my paths. So I'm going to click on the add path button right here, and then we'll add a path from mastery to interest. You can see that now we have a residual associated with interest, interest to achievement, anxiety to achievement right there, performance goals to interest, and then also to anxiety right there. Let me just kind of get that drawn back in right there. So now we have our 3 error terms associated with our 3 endogenous variables. If I click this little double-headed button right here for add covariance, I'm just going to draw up right here, and you can see that we get our covariance between our exogenous variables. We can also delete that if we want. If we make a mistake in our model, we can certainly use the delete button to delete anything that we want. But again, I'll just kind of redraw this so that we have that covariance between mastery and performance goals. Okay, so I'm just going to go up here, click on the select button right there, just kind of select everything off, and then we'll go to estimation and click on estimate. So you'll notice that we've got 3 estimation options. We've got maximum likelihood with missing values, and then asymptotic distribution free. So it's really rare to see anyone use asymptotic distribution free. We have maximum likelihood with missing values. So if we have missing values in our data set, which we actually don't, so I'm just going to stick with maximum likelihood right here. But if we had missing values in our data set and we wanted to use the full information maximum likelihood option to account for the missing values, then we could click on this button right here. If we have missing values and we use the top option, then basically we'll have maximum likelihood that's used to estimate the model parameters, but the cases would be deleted in listwise fashion. So again, we're just going to stick with the maximum likelihood method, the default for this particular demonstration. So next we can click under standard error robust tab right here. This is to get various standard errors for use when we're carrying out our tests. You'll notice that we have default standard errors, there's robust standard errors right there, there's bootstrap if we want those. I'm actually just going to leave it on the default. Under reporting, you'll see we have various options for reporting various estimates within our model and so forth. If I click on display standardized estimates, basically this button right here, then the path coefficients and so forth within our model will all have the standardized estimates showing up in the diagram. I actually just want to leave this alone, and I'm going to click off of this and just so that I get the unstandardized estimates. Next what I'll do is I'll click on OK, and so now the model is being run. And so now basically we have our unstandardized estimate showing up. So there's the unstandardized path coefficient from mastery goals to interest, from performance goals to interest, from interest to achievement, anxiety to achievement, and then performance goals to interest, right, to anxiety right there. You'll also see that right here, this is the covariance between mastery goals and performance goals. And then you'll see that these numbers right here, these are essentially the error variances associated with basically for the interest, achievement, and anxiety variables. And then over here you've got the variances for mastery goals and performance goals, and then these are the estimated means for those two variables as well. If I want a little bit more detail, I can actually click on a given parameter, and you'll see the box to the right shows up. It says details. It's got the coefficients up here. These are the unstandardized coefficients, standard errors, z-values, p-values, and confidence intervals. And then down here we've got standardized coefficients. So technically speaking, I didn't have to click that button to get standardized estimates because I can get them over here just by clicking on a given path coefficient. But if I wanted the standardized estimates actually in the path diagram, then I could have selected that option before. So at any rate, you can see that as we click from on different parameters, you can see that those details change accordingly. Okay, so after kind of minimizing the diagram, you can see that we have information in the main Stata interface. So you can see up here, this is just the model specification. You'll see that right here it's got mastery, arrow to interest right there. Performance goals, arrow to interest, then performance goals to anxiety, and so forth. So that's the basic syntax for specifying the paths within our model. We're just using the SEM function right here. So if we scroll down, you can see that we have a table that contains our various parameter estimates. So you'll notice that we have a column of coefficients. Right now, these are basically unstandardized path coefficients or variance estimates. Basically, all the way down to about this point right here, these are all going to be regression coefficients. And you can see that we've got the means for the mastery goal and performance goals variables, and then you've got different variance estimates that are given right here. So it's got variance E dot interest, E dot anxiety, E dot achievement. So these are basically the residual variances right here. And then you've got VAR, mastery, and performance goals. Those are the variances for those two exogenous variables right there. Okay, so in the interest of just making this a little bit more readable, we're just going to go back to a screenshot in my PowerPoint. So you can see right here we've got mastery predicting, there's our arrow, the interest variable right here. So this first box is basically contains the regression coefficient or the path coefficient for the path from mastery to interest. We have the standard errors, z-values, p-values. There's even a 95% confidence interval formed around our estimate. So you can see right here that basically mastery goals is a significant positive predictor of the interest variable. So basically students scoring higher on mastery goals are predicted to score higher with respect to the interest variable. And again, if I wanted this information, if I wanted the standardized path coefficients, you can see that going back to our diagram right there, this B right here, this is essentially the standardized path coefficient for the path from mastery goals to the interest variable. Okay, so next you can see that performance goals was not a significant predictor of student interest. And you can see that performance goals was not a significant predictor of anxiety. But we do see that interest is a significant positive predictor of the achievement variable. So basically students scoring higher on interest were predicted to score higher with respect to achievement. And then the path coefficient from anxiety to achievement was negative. And we might consider it to be statistically significant using a one-tailed criteria. You can see right here that if we want to test the covariance between mastery goals and performance goals, this is our covariance estimate. You can see that it is statistically significant right there. If we wanted just the correlation between the two, then this would be the coefficient that's given in the details table. One other thing to note too, you'll notice that we've got right here the CONS right here and here. This is just basically the intercept for each of our 3 regression models that make up the entire path model. Okay, so once we've looked at as we're going through our interpretation, we might be interested in evaluating the overall fit of the model to the data. So we can use post-estimation commands to do this. So there's actually, you can use syntax to do this, but I thought I would go ahead and demonstrate using the post-estimation tools using the drop-down menus. So what we'll do is we'll go back in and open up Stata where we left off. And we will go up to statistics down to post estimation right here. We'll click on specification diagnostics and goodness of fit analysis, and then we'll click on overall goodness of fit. So you'll notice that there are a number of different pieces of information that can be requested. We're going to leave it as goodness of fit statistics, GOF. We'll click this little drop down right here, and we'll click on all of the above and then OK. And now you can see that we have our model fit statistics. Okay, so going back to our PowerPoint and just kind of walking through the interpretation. Again, I'm using this to make it a little bit easier to read, but you can see right up here we've got a chi-square goodness of fit test. And so basically, if this test result is statistically significant, then that would be taken as an indicator of poor model fit. So you can see right here that that happens to be the case. One thing to keep in mind is that this is really probably the oldest of the fit indices. And nowadays, researchers still report on it, but they don't spend a whole lot of time with this in terms of judging model fit because the chi-square test is impacted by sample size. And given that SEM is a large sample technique, we can have minor evidence of poor fit, or basically minor problems with our model fit, but yet we find it statistically significant, and then we end up rejecting the entire model when maybe it's not a terrible model to begin with. So we do use other indices nowadays, which would include the RMSEA, the root mean square error of approximation, the CFI and TLI, that's comparative fit index and Tucker-Lewis index, and the SRMR, that's the standardized root mean square residual. So you'll see right here that just with respect to the RMSEA, the lowest possible RMSEA value is 0, and so basically values up to about 0.05 suggest that a model is exhibiting close fit to the data. Values up to about 0.08 would be still considered acceptable. So you can see right here that our model is definitely not suggesting good fit, or this index is definitely not suggesting good model fit. This p-close test right here, this is basically a test of whether the model fit is significantly different from what we would expect if it was a close fit. So you can see right here that's essentially that the RMSEA would be less than or equal to 0.05. So if this test result right here is significant, then that would indicate poor fit, and so that's clearly the case right here. Okay, so next let's look at the NFI and the CFI. And actually, please excuse me, I refer to the NFI. The NFI is a non-normed fit index, and the TLI is Tucker-Lewis index, and they are the same, but they are sometimes they're called different things in different programs. So in Stata, it's referred to as the TLI, or the Tucker-Lewis index. So excuse me on that. But at any rate, basically what we're looking for with respect to the CFI and TLI, when we have values that are above 0.95 for these indices, that would be suggestive of a very good fit. Values that are 0.90 or above would be still considered acceptable fit. So you can see right here for both of these indices that we have evidence of poor model fit. You can also see that we have the standardized root mean square residual, and so values up to about 0.05 are considered as indicating close fitting model. Values up to about 0.10 would still be considered acceptable fit. So once again, it looks like that we have evidence of a poor model fit based on that particular index. So overall, the model is not showing good fit to the data. Now we can further unpack the issue of model fit and maybe kind of diagnose potential areas of misfit by using our post-estimation command again and obtaining matrices of residuals. So just keep in mind that with respect to SEM, what we're basically doing is we are fitting our model to a data set, and there is basically the observed covariance structure within the data, and then we have a model implied covariance structure. So the difference between the implied covariance structure based on our model and the covariances found in our actual data, those are referred to as residuals, and so we can essentially use residual matrices to identify possible areas of model misspecification. So the way I can obtain that information is to go back under statistics, post-estimation, and if we go back under specification diagnostic and goodness of fit analysis, you can see under matrices of residuals, it says display mean and covariance residuals. And most of the time, it's really most helpful to look at the standardized residuals. So I'm going to click on that and then click on OK so that we get our matrices. So you can see right here that we have a matrix of covariance residuals. So again, this is basically reflecting the difference between the observed covariances based on our sample data and the covariances that are implied by our model. But the standardized covariance residuals can be useful for identifying potential areas of misspecification. And so what we're looking for in this matrix are values that exceed 1.96 in absolute value. And so you can see right here that we've got multiple areas within this matrix that exceed that threshold. And so potentially by adding in additional parameters or respecifying the model in different ways, these values would become closer to 0. Now if we want to further explore possible options for respecifying the model to improve model fit, we can generate modification indices. Now I do want to mention modification indices are highly controversial, and just keep in mind that as you start tweaking or modifying your model in order to better fit your data, you lose the possibility or the possibility of the final model fitting as well in a replication sample will be lower. And basically that's because you are potentially capitalizing on chance as you are trying to improve the fit of your model relative to your current data set. But nevertheless, if we want the modification indices, we can again use our post-estimation option right there. We can go under here. You can really kind of click under any of these, but I'll just go ahead and I'll just go back and click under matrices of residuals. And you'll notice that right above it, it says modification indices. And so you'll see it says restrict output to parameters in specified parameter classes. I don't really do anything with that, but down here it says display only tests with modification indices with values that are greater than 3.84. And basically that is a tabled chi-square for 1 degree of freedom and a p-value at 0.05. So the modification index is basically a chi-square value and represents the predicted decrease in the overall chi-square value for the model by adding in a specific parameter that is suggested. So what I'll go ahead and do is just click on OK, and so now you can see that I've got a table containing the modification indices. So again, you can think about the modification indices as kind of suggestions for possible model respecifications where you're adding in additional parameters. Now keep in mind, first off, you want to make sure that you are, if you're going to modify your model by adding in additional parameters based on these indices, you do need to make sure that those additional parameters are theoretically defensible. So the modification indices are agnostic concerning your model. It doesn't care about the theory and so forth. This is just basically a projection as to what would happen to the overall chi-square goodness of fit value if we add in a parameter. And so the MI is basically reflecting the projected decrease in the chi-square value by adding in a specific parameter. And basically decreasing chi-squares are indicating improvements in model fit. So basically, as I noted before, a value of 3.84, which was our threshold for even showing up in this table, would suggest that including a suggested parameter will result in a significant improvement in model fit with alpha at 0.05. So you can see that all of these values are greater than 3.84. So these are all possible parameters that could be added. So you'll notice that there's a possible parameter to add between achievement and interest. So achievement predicting interest. You've got interest predicting anxiety, mastery predicting anxiety, mastery and performance goals predicting achievement, and so forth. But again, these are not necessarily theoretically defensible, and the more changes that you make, the more you run the risk of capitalizing on chance. Down here, these are possible error covariances. So basically the covariance between the residuals for interest and achievement right here, and then the covariance between anxiety and achievement right there. So that's what those are. And then the last couple of columns, the EPC and standard EPC, these are expected parameter values should you choose to respecify your model with a given parameter being estimated. Okay, so now let's consider a second model. So in this second model, what we're going to do is have mastery goals serving as a predictor of interest, achievement, and anxiety, and then performance goals only having a direct effect on the achievement variable right here. So we'll go back to our model right here. I'm going to go up under estimation and click on clear estimates to get rid of everything. And I am going to highlight this path and delete it, and then I'll highlight this path right here and delete it, and then we'll add in a path from mastery to achievement, and then from mastery to anxiety. So let me add that in as well, and then we will add in performance goals to achievement as well right there. Okay, so this is the same as the drawing in the PowerPoint. And so now we're ready to go. I'm just going to select off of everything and then go back to estimation, and we will click on estimate. We'll leave everything pretty much the way it was, so we'll click on OK right there, and now we have all of our estimates. And once again, if you click on individual paths and so forth within the model, you can get details regarding each of the parameters within your model. And if we go back to our main screen, you can see that now we have all of our parameter estimates are given along with the test statistics and so forth. Okay, so really quickly, one thing that I forgot to do in this respecification, I forgot to include a correlated error between these epsilon 1 and epsilon 2 terms. So basically, we're in this particular model, I wanted to include allow for the error terms to be correlated. So let's go ahead and go back in and respecify it with the correlated errors before we go into interpreting a little bit more. Alright, so here we are back in the drawing program, and I'm just going to go back under estimation, kind of clear things out, and we will then use our double-headed arrow, add covariance. So I'm going to click on that, and then just basically draw from one error term to the other. So there it is right there. And we'll just kind of click through right there and then rerun it. So I'll go back to estimation, estimate, and click on OK, and there you go. So this was the basic model that I wanted to show you. So at any rate, just kind of scrolling through the output again, this is going back to the PowerPoint and showing you the various pieces. So you can see once again up at the very top we have we have the code associated with the model, specifying the model and so forth. When we scroll to the next screen right here, you can see I'm just kind of laying out the relationship. So we can see that mastery goals, that coefficient from mastery goals to interest was positive and significant. So again, students scoring higher on mastery goals were predicted to score higher on the interest variable, and you can see right here under the details box there's our standardized path coefficient that's given right there. We see that the path from mastery goals to anxiety is negative, and we have statistical significance there. So students scoring higher on mastery goals were predicted to score lower with respect to anxiety. Then we have the path from interest to achievement. That path is positive, and we have statistical significance of this path right here. So students scoring higher on interest were predicted to score higher with respect to achievement. Then you can see that the mastery variable, the path from mastery to achievement, that path is positive and significant. So students scoring higher on mastery were predicted to score higher on achievement. And then you've got a negative path coefficient from performance goals to achievement. And you can see that we have statistical significance. So basically, students scoring higher with respect to performance goals were predicted to score lower with respect to achievement. Then down here you can see that I've added in once again, this is the covariance between mastery goals and performance goals, and that was significant. But then the correlated error for the interest and anxiety variable, that was actually non-significant. And just so you know, the error terms, we can refer to them as residuals. Another term you might hear used in the literature is disturbance term when you're talking about the prediction errors associated with the endogenous variables. So that's kind of why I use that term right here in this description. So going back and requesting the goodness of fit information, the general overall model fit information, you can see that the likelihood ratio test, basically our chi-square goodness of fit test, is not significant, which is suggesting a good model fit. RMSEA is 0, and the p-close test is not significant. Both of those are suggesting good model fit. The CFI and TLI are clearly above the 0.95 threshold that I was mentioning before, and SRMR is 0.021, so that's below 0.05, which is all of those are suggesting close model fit to the data. So here we're back to Stata, and we'll just go ahead and I'll just show you once again how you can generate the goodness of fit measures by going under post estimation right here. Under specification, diagnostic, and goodness of fit analysis, you can see overall goodness of fit. We have it set for all right there, and click on OK. And so now we have all of our goodness of fit statistics. And if we want our matrices of residuals and our modification indices, we'll go back under post estimation. There's matrices of residual right there, and reporting standardized residuals. When we click on this, you can see that basically all of the values are much lower than what we had before in this particular matrix right here. So the values are, none of those values are at 1.96 or above in absolute value. Again, if we want to look at the modification indices, we can just go right back through this if we want. Click on modification indices and click on OK, and so now you'll see it says no modification indices to report. All modification indices values are less than the 3.84. So basically there are no further suggestions that's being given concerning model additions that might result in improvement in fit. Now, something else that you might want to request are the R-square values associated with the equations. So you can see right here, going back to our basic model, again we have mastery goals predicting interest right here. We've got mastery goals predicting anxiety, and then achievement being predicted by all of these variables right there. So if we want the R-squares for those three endogenous variables, we can do that by going to statistics, post estimation, go back under here again, and then go down to equation level goodness of fit. And so when we click on OK, you can see that now we end up with a table that contains the R-square values for each of our three endogenous variables that are given right there.